Good morning.
Good morning.
Hey, morning, Ted. Stephen here. Hey, Deepak.
Hey, Stephen. Hi, good morning, everyone.
Good morning.
Oh, Tim cannot unmute. I don't know who is the host of this meeting. It should be fine.
Tim. Usually it's Tim. He's
Tim
having trouble. He said he just dropped it.
Yeah.
Okay, I'm back, and this time I can talk.
Okay. Great.
Let's give it just 1 minute. Okay, we can get started. And just a quick announcement: we were going to review. Rebecca was from Meta was going to review adaptive query execution support in Sapphire, adaptive optimizations, but she's feeling under the weather, so it'll be next time. So just the agenda is just Prestissimo MVP. I think that's from Deepak. And then discussion around supporting hive.metastore equals file. And
Yeah,
anything else that we want to bring up. Sorry, so, is someone talking?
Oh, no, sorry. I just said I added that as well, the official support.
Cool, that's awesome. Great. So on to you, Deepak. Presto Prestissimo MVP.
God, thanks, Tim. Let me share my slides. Can everyone see my slides okay?
Yep.
Great. So last TSC meeting, I briefly spoke about the Prestissimo project and the module in Presto now. Let's quickly recap what it is. So as I mentioned, it's a C++ worker implementation for Presto. It's a drop-in replacement for the idea is to make a drop-in replacement for the Java worker, and it implements the HTTP protocol. So it's basically it's in line with the Presto specification, and the main idea is to build it on top of the logs, and the goals are high performance, extensibility, and also help with consolidation. So those are the top goals for Prestissimo. All right. So why do we need an MVP for Prestismo, which is essentially a minimal viable product? We feel we had some discussion in Hana as well, and we feel from a community perspective, we need some at least a minimum functional set for better adoption and user experience. Releasing something too early might end up sort of not well adopted and also lead to some confusion. So we feel when we officially announced. So right now, Prestismo is sort of informally announced. It's part of the Presto project, but we haven't made any official announcement on it. But we feel we should have at least some features before we officially announce it. And I'll go through what I feel those should contain. So the MVP, in my view, contains two categories: the functional features and also the performance and robustness part. All right. Any questions before that? All right. So what are the functional features, right? So obviously we want parity with the Java worker. So we have to implement the protocol itself correctly. So that it is a drop-in replacement. So we have the protocol implemented and we are testing it via some end-to-end tests inside Prestissimo, and we're hoping, and the current hope is that that's sufficient to sort of test the protocol implementation. And for instance, any connectors that are not implemented will sort of break because the protocol bindings are not present. So that's the current test coverage for the protocol itself is by adding end-to-end tests inside the CI jobs. And then we also want all the data types, functions, and statements in the Presto manual or the documentation covered. And then one way to sort of reach this or achieve this is to have TPCH and TPCS coverage as proxy. So the current plan is to get enough coverage to run all the TPCH and TPCS benchmarks, and that should give us a good sort of proxy for this goal. And then we also want the Hive connector because that's the most popular connector in Presto. So we want complete and good coverage for that, which includes supporting the Parquet and Orc file formats and WAR file formats, and also read and write support to these file formats. And the current hot trend is this data lake table formats like Iceberg, Hoodie, and the lake. We also want coverage for these table formats in Prestissimo. So yeah, that's one of the goals as well. Any questions on this list of functional features? Cool.
I'm waiting for the next slide where the non-functional questions get to go.
Sorry, Ted, could you repeat that?
I'm waiting for where the non-functional implementation.
Got it. The performance and robustness.
Goes, yeah.
Yeah, got it. Yeah, this is one more slide on the functional part. So apart from that, apart from the functions and connectors, we also want the metrics to be supported. So we want, just like we have on the Java side, GMX, and we have some other API to capture metrics. We also want that on the Prestismo side so that we have better visibility on the execution and also the performance. And yeah, security as well is one thing that we are considering. So Java supports column level masking and encryption support for, I think, Parquet at least. So we want something equivalent on the C++ side as well. All right, so that's sort of the functional side of things that we feel should be in the MVP. Now, the performance and robustness is sort of obviously the most important piece. Like I said, the whole goal of Prestismo is to have better performance and significantly better cluster performance and reduction in number of nodes compared to the Java. So on that angle, we want the ARIA optimizations fully supported, which includes like filter pushdown, not just to the table scan, but through various stages in the execution. And we also want columnar and SIMD execution as well. So this is one of the topmost priority. And I think we have good coverage here in the current implementation, but we continue to test more workloads and bigger data sets to sort of fine tune this layer, this implementation. And
So,
the other, yeah, go ahead, Ted.
a big question here is that certainly fashionable and certainly easy lately is all this buzz about DuckDB.
Right.
They have C++, SIMD execution
Correct.
for a lot of things. How much of that can you just lift?
You mean reuse DuckDB's implementation or just
Yeah.
Yeah, it's not easy to lift. So we use so I think I can give some background. Ying is here too. She can give some details too. So we don't handwrite this SIMD code today. We use this XSIMD library to sort of lift some of the SIMD code writing. So that also gives us portability. Like I think XSIMD supports both ARM and Intel processor. So there's that we use to sort of minimize the inventing the wheel. But to reuse the SIMD layer itself, I don't believe there's much value from DuckDB because like XMD gives us enough abstractions to sort of achieve that. So that would be my short answer. Ying, do you have any thoughts on top of that?
Yeah. So what Deepak said was correct. Yes. So DuckDB, I believe it has a different objective when designing their code. I think portability is important to them, so therefore they didn't use SIMD in their code. And also the some of the implementation it could be better. So that's why we started the native Parquet Reader project. So so our existing, so current testing shows there are like around 5 or 6x better performance in the native Parquet reader than the DuckDB one. So it's still ongoing. There are several types that needs to be done. And we are doing some refactorings and making the decoding better. So we're pushing the filter not only to the decoded data, but to the encoded data as well. And there are several other so new inventions there. So so we look forward to see its new performance numbers. It should be improving even more than the current implementation.
Well, that's impressive. Cool.
Thanks, Ying. So that's the story around SIMD and common execution. And the other performance angle is the IO caching. So we have RaptorX today for Java, but on C++ side, we have a native cache that's even better than RaptorX. Like it does in-memory caching, and it's more adaptive in the sense that if it sees that there's free memory available, it can sort of use it for caching, or it can sort of go to just pure SSD cache if the memory pressure is high. So there is, I think, except for the result set cache, we have everything in terms of what RaptorX provides for caching. And the IO subsystem optimizations as well are important. I don't know exactly what Java supports, but on the C++ side, we have prefetching, asynchronous IO. We do parallel we do parallel loads to some extent, but we can, I think, improve on that. And also we have this important read coalescing, where if we know if 2 reads are close by, then we can just do 1 read and get away with 2 calls. And this is especially important for cloud storage, where each API is sort of expensive. Like you pay a cost for each API. So like a GET request, for instance. So this helps a lot in reducing the cost as well when you coalesce these reads. Any questions on the IO caching and the IO subsystem optimizations? All right, so the other performance robustness angles are the spilling, which is super important for if you want to efficiently utilize the disk and have support machines that have lower memory available. and resource management. So we also want to efficiently use the memory. Like I said, we have this nice adaptive cache for memory, and also the operators themselves can request memory or let go of memory based on the priority. So that's still work in progress, but the whole goal of Prestige would be make most of these adaptive and avoid configuration options for these. I guess that's sort of the performance robustness side of things, and we believe should be in the MVP. Yeah, I guess that's the end of my slides as well. Any questions, any concerns on the MVP?
How long do you think to MVP?
Good question. Depend, at least another year, I would think, for MVP. I think some are more important than others. Like for instance, the table, the table lake formats, for instance, Hoodie, Iceberg. Even on the Java side, they're work in progress. They're actually building new connectors, and we don't believe like they're the best way forward. So, like connectors would probably be not like a blocker for MVP, but performance robustness definitely. And I think we have all of this in place on the performance robustness side. We just need to test like intensively with bigger data sets and profile them and sort of understand them better. The functional side will be work in progress. Like I think we have most functions, for instance, on the Prestige side, but the not popularly used functions probably can slip through the MVP.
Yeah, it's a pity that the data lake formats can't just devolve down to a Parquet reader.
Yeah.
They wind up as in Parquet below there. If you could plan through the data lake part of it, then
Right.
it would just be a bunch of Parquet files.
Exactly. That's exactly. I mean, Hoodie has this merge on read, which requires some more work probably, but like you said, all of them should be able to use the Hype connector and yeah, do the planning stuff like the listing and planning on the optimizer without having to impact the execution engine layer.
Can you mix and match Prestissima and conventional Presto workers?
Not today. The page protocol is the same, but yeah, we don't have any testing on that side. We don't have any end-to-end test where you have a worker in Java and worker in C++.
That's not an intent either, it sounds like.
That's not an intent either, correct?
That might have been a way to avoid as much feature creep in the MVP if you could plan Java only queries or C++ only queries.
Yeah, but from a product angle, that wouldn't be ideal, right? Like you will have to spin a Java cluster, and how do you like resource manage the memory between the two? It's sort of
No, it isn't simple.
yeah, it's simple. So I mean, ideally, we want like some capability on the Java C++ worker. Like I mentioned this in the last talk, which have some way to offload the Java only tasks, like to a GNI or through a coprocessor or something like that. But that's later. That's not part of the MVP.
JNI is still evil, even after all these days.
Sorry, Ted, could you repeat that? GNI is what? Sorry,
It's still evil for performance.
evil. Yeah, yeah. I mean, the ideal would be to sort of not have much on the worker side, like specifically creep, like you said, feature creep on the worker side. Like for instance, what's happening with the data lake table formats? Like we're adding a new connector without much benefit. So that's something if you can avoid, it'll be great. All right, so yeah, I guess we can always discuss further on Slack. There's a Presto CPP Slack channel, and yeah, we're happy to get more feedback and inputs on this because we really want to make Prestige more first-class citizen in Presto and want everybody to enjoy the benefits from this nice C++ optimized execution.
If you haven't yet, it'd be good, I think, to take all the functional and non-functional features and create GitHub issues for them. Just so like, like perhaps we could get more around
Definitely.
specific to Prestissimo support.
Definitely. Yeah, we had some on the Presto CVP repo, but now that it got moved to the Presto side, we have to, I guess, move some of them. Yeah, I'll work with Ethan on this. Ethan is our director on this, so we can get it working.
Great.
Cool. I see Rebecca now. Is Rebecca planning to present the next topic, or should I go to the Hive connector file?
I think Rebecca will be doing next time, so
okay.
We can skip on to your next topic. Okay.
Cool. Yeah, this won't take much time. So there was actually, I mean, when I started working on Presto, I found the inability to not directly read Parquet or org files little interesting. Like when I came from Vertica, and Vertica, we had this feature where you can just point like an external table to a directory with Parquet files or org files, and you could just read off that. The schema would be inferred because Parquet already has the schema in the file itself. So obviously you assume there's no schema evolution and all files have the same schema. So that's sort of a common case. So that sort of ability was missing in Presto, and I always wanted to have something. And informally, I got to know there's this presto.hive.metahistorical file by looking at the testing we use there, but it's not formally supported. And I also saw this question on the Presto discussion space which basically asks the same thing: how do you read a set of Presto or Parquet files locally without having to spin a catalog or a catalog service? So yeah, my thought is, why not formalize and document this hive.metahistorical file functionality, and allow users to be able to directly read Parquet files without having to spin a catalog service. Obviously, the schema creation needs to be answered. So we could have an external tool where we can write. So right now, I think the way it works is when you have a Hive metahistorical file and you create a table, it creates this .presto schema files which has the schema. We could have a tool to automatically generate that file. Like say you point to a directory and we can generate those files, and we can then have Presto to query these directly with Presto or Parquet files. Any thoughts on this?
Maybe that could be done on startup. Like, we see the directory, and like we just we just generate those .presto files.
Exactly. Yeah, you're right. When we're loading the catalog, and yeah, we could see the tables, and we can sort of, yeah, we can do that too. Yeah. So yeah, but there are no objections to sort of officially support this, right? I feel it's going to be very helpful for users to sort of move to Presto if we avoid one step of sort of spinning a catalog, and if we support this.
It's an extremely good feature, and it's heavily used in Drill and in DuckDB. Both places, though, that you don't need to do any Hive Metastore hacking at all. Duck's approach to it is to use a table function.
I see.
And that allows you to specify extra stuff to help with that. And it prevents you from needing an external metadata service. That also allows you then to do views, which encapsulate and hide the table function. Drill especially had issues with the cost of scanning large directory trees. And you face that problem either if you scan at query time, which is disastrous if it's going to take 30, 40 seconds just to scan the directory tree, or at startup, because you want to look for, even if you're caching all the schema, you need to do a stat on every file to figure out what's changed. And that's bad enough on a file system. It's worse on a distributed file system, and it's completely evil on an object storage system. And so there's that problem. If you can make that more explicit, then you can be a little bit more aggressive about it.
Yeah, the idea is like we assume, like we make some simple assumptions, like all the files have the same schema. Ideally, this is mostly like for a smaller data set usage.
Yeah, like would optimizing for these directory listing calls like be so you can like I picture this connector being, or this way of querying being useful for like, development.
Correct, exactly. Yeah.
It's a pretty common production setup because it is so slick and so easy and so clean. The incremental processing is very, very simple. And so it vastly simplifies data pipelines to use this. It's a really nice thing to be able to do. You have to watch out for the scan time. And if you can avoid it, however, it's very nice.
But one, it sounds like Deepak, like it sounds like we can just kind of like configure the Hive like the Hive connector in a certain way to use local files, and then like maybe we need to add some metadata to like that might be kind of like the largest part of the code change.
Exactly, because listing is a common problem. I mean, even irrespective of it, right? Like I think, for partitions, you have to list in the regular case. So,
and I was just thinking, like, the Hive connector already kind of like does the partition discovery asynchronously. So,
correct.
A lot of the, like it might not be that, like it's basically the time to first file or first group of files might be affected, but because it's asynchronous, it may not be that bad. Like we might not have to optimize for it.
And then one other thing is that requiring exactly identical schemas is onerous. It is far preferable to allow for exact match among the columns of interest or allow columns to be missing. And don't care about columns that aren't in the query if that's at all possible, and allow columns to be missing. And the reason for the missing is just so that you can do schema mutation over time by adding columns.
That I believe is already supported. Like if you match schema by name, I think you can get some schema evolution. I think the whole goal here is like just the initial phase. We want to get some schema, and sort of overcome an additional service to get that schema. But the remaining like listing and all should sort of follow the standard Hive connector pieces. That's my understanding.
Yeah, well, Hive connector has issues. It embeds data values in file names, for God's sake, which is a huge privacy problem. Suddenly, directory listings and stack traces contain private information. This is bad. But what I was saying is that it would be really good to relax the exact matching. So it isn't a schema by name, it's this file should be allowed to have a slightly different schema than that file.
Got it. Even the order of the columns, I see. Okay.
Yeah.
I understand, like what was the need to have these .presto files? Is that like a Parquet requirement?
For the you mean the Presto schema files, Tim? Yeah. I mean, I just noticed them when we created. I guess it's not a Parquet requirement. It's just for the Presto Hive connector to work. I think if it's a file-based metadata metastore, then we look in the Presto schema file to get the schema, I believe.
I see. Okay, I didn't know about that.
Yeah, I just noticed like whenever you create a table with this Hive metasecurity file, you get this .presto schema files and some with some security details, like if you can delete the table on. I think you get all the Hive metastore, like what are the table contents as a file, and then the Presto connector can just Hyperconnector can just read that file to sort of get the semantics or the metadata.
Got it.
Yeah, I can go. So I guess I'll open an issue at least for this on Presto, and then we can I'll share what the Presto schema currently has, and then we can, I guess, iterate on that over there.
Yeah, I think it'd be great to at the very least like kind of like as you're mentioning, just like make it explicit, like how you can sort of already do this,
Right.
but then also like fill in the functionality gaps and
Correct,
make it more of like a first class thing. That'd be a great community contribution.
Yep. All right.
Yeah, just to chime in here. So I think Hive also, there was some issues open in Hive also to have this functionality of reading the schema from a Parquet file. So there is some proposed patch where there's a create the external table itself can read the schema from the Parquet file and create the table definition in the Hive Metastore. So it's not exactly what you're looking for because you are looking for serviceless, but I'm just putting it out there. There's that can be an incremental benefit, is that if Presto can support that, then at least you can read the schema. You don't have to write it out and create a DDL, and at least you have your table definition in the Hive Metastore.
Yeah, that's a good extension too. Like, yeah, users shouldn't have to specify schema. They can.
You don't have to specify a schema, and then it can be partition-based table. You can just do a repair or to add additional partitions to the Hive Metastore and all that. So just putting it out.
Yeah, definitely makes sense.
Okay. Any other questions on this or any other topics anyone wants to bring up? Okay. I don't see any unmutes, so it looks like we'll close it out early. Thanks, guys.
Thanks, everyone. Thanks for your time.
Bye.
Have a good week. Bye.